Leshire Mathematics here. Today we are going to still discuss question number 9. And question number 9, here we have a figure, says that figure 4 shows a sketch of a design for a logo. The design consists of a rectangle of base x centimeters and height y centimeters with 2 quarter circles of equal radius. So there are two things already that is mentioned here. We have a rectangular base, x centimeters, and also we have height, y centimeters. Then we have 2 quarter circles. Their radius is r centimeters. So if there are 2 quarter circles, then definitely that means we'll have a semicircle. Then we are given with a gap of 10 centimeters between the nearest point of each quarter circle as shown in figure 4. So this one we've been given on the diagram. That is the gap. Part A here says that show that the radius A square centimeters of the design is given by A is equals to xy plus pi over 8 into x minus 10 square. Now the first part here, what I will want us to do, since we are given radius and the variables here we have x, y and r, so we can express r in terms of x because the 2 quarter circles are attached to the opposite side of the length, which is of dimension x centimeters. So here we can say that the radius, definitely this one will be equivalent to 10 minus x, the other way around, not 10 minus x, but radius is x minus 10 everything divided by 2. So that is simply the radius. Now with this in mind, we can start with part A. Part A, we can say that area itself is the same as length plus width, length times width, that is the area of the rectangle, plus the area of the semicircle that are composed by 2 quarter circles. This one will be half pi r squared. Now remember that r we've said already to be equivalent to x minus 10 everything over 2. When we substitute everything that we have, length is x and y, w is y. So this means that the area will be equivalent to xy plus a half pi into x minus 10 everything over 2, then we square this. So what we can do, we can simplify the denominator of what is in the bracket, so that we'll have your area here as equals to xy plus half pi into x minus 10 square. Of course 2 squared gives you 4, so this one is over 4. So simplifying further, we can say that the area here will be equals to xy plus 2 times 4 gives you 8. So this one is the same as pi over 8 into x minus 10 squared. So here we can say that hence shown, that is part A. We can go ahead and simplify part B. So our part B here, going back to the question, part B, given that the total area of the design is 1 square meter, so that is worth noting. The total area of the design is given as 1 square meter, and recall that 1 square meter as a square centimeter, because the dimension of the logo design is given in terms of square centimeters. So we'll have this at the back of the mind that 1 square meter is just the same as 10,000 square centimeters. Then the second part, the perimeter P of the design is given by P is equals to 2y plus 2 plus pi over 2, close the bracket, x minus 5 pi. So part B says show that P is equals to 20,000 minus 25 pi over x plus 2 plus pi over 4 x. Now going back by part 2, that is part B here. Part B, you are given the perimeter to be equivalent to 2y plus 2 plus pi over 2 x minus 5 pi. So this is what we are required to prove, to show that. So we want to use what we are given to show that the perimeter is given by this. Now what are you given up here? What are you given up here? What are we given up here? Going by what we have, so the first step in this case is 1, we know that area is given as 1 square meter, and 1 square meter translates to 10,000 square centimeters. So that means we'll equate what we have up here, we'll equate this one to 10,000. So therefore we can say that xy plus pi over 8 into x minus 10 square, this one should be equals to 10,000. What else are we supposed to have here? What we can do, I will want us to take pi over 8 into x minus 10 squared, the other side of equal sign, so that what we only remain with on this end is xy should be equals to 10,000 minus pi over 8 into x minus 10 square. Expressing this in terms of y, so we are using the given condition to express this in terms of y, so we can simply divide through by x, so that what we'll have here, we'll have y y will be equals to 10,000 minus pi over 8 into x minus 10 square, everything divided by not 8 but everything divided by x. Now what do we need to do? From the perimeter where we have y, we can simply replace with the expression here, so that your perimeter, in this case, perimeter will be given as, if you substitute the value of y, perimeter will be given as 2 over x, open a bracket, this is 10,000 minus pi over 8, open the bracket, x minus 10 square, close the bracket, plus 2 plus pi over 2 of x, then minus 5 pi. Now what we can do at this point is to first expand the bracket, or simplify the first bracket. Simplify the first bracket. So simplifying this first bracket, maybe I can use a different pen or a different color. Simplifying this bracket, we will have 2 over x, open the bracket, 10,000 minus pi over 8, and what we are going to have here, remember x minus 10 square, x minus 10 square, we can simplify this as of course this one, x minus 10 squared can be expanded to give x squared minus 20x plus 100. So that is what we are going to substitute here, so that we open the bracket, this one will be x squared minus 20x plus 100. We close this bracket and we can simplify this. This one equals to, just open the bracket, or we can first open the inside bracket. So we'll have 2 over x, open the larger bracket, 10,000 minus this one will be pi over 8 x squared, and also pi over 8 times negative pi over 8 times negative 20. This is just the same as 20 negative 20 divided by negative so negative 20 times negative 1 over 8, and this one will be positive 5 over 2 pi x, then negative pi over 8 multiplied by positive 100. So this one will be minus 25 over 2 pi, then we close the bracket. Now we can still simplify this. We'll say when we simplify this, this is what we are going to have. This one will be equals to, opening this bracket, it means what we are going to have here, when you open this bracket, it will be 2 over x times this one will be 20,000 over x, 2 over x times negative pi over 8x squared. So this one will be minus pi over 4x, then 2 over x times 5 over 2 pi x. Of course 2 and 2 cancels, x and x cancelled, so this one will be plus 5 pi, then 2 over x multiplied by negative 25 over 2 pi. So this one will be minus 25 pi everything over, of course, over x. So we've expanded the first bracket fully. So incorporating this into the original function of the perimeter, then this is what we're going to have. So we'll say that P will be equals to 20,000 over x minus pi x over 4 plus 5 pi minus 25 over 2. So 25 over x, not over 2. 25 over x pi. Then we'll add to, of course we can expand this too. So when we expand this, will be 2 times x gives you 2x. Then pi over 2 times x gives you plus pi over 2x, then minus 5 pi. So up to this point, collecting the like terms, definitely. If we collect the like terms here, these two will cancel out. So that what we'll have here will be P equals to 20,000 over x. We can also simplify negative pi x over 4 plus pi over 2x plus pi over 2x. So this one will give you, so we can start with the first minus 25 over x pi. Then let's find out, of course this one we can use a calculator here, just quick one. We'll have, so this one is a negative 1 over 4. We'll just pick the coefficients, then we add to a half. So what does this give you? It gives you 1 over 4x. So that is what we'll have. So this one will be, of course, we'll have plus 2x, then minus pi over 4x minus 5 over 4, so pi over 4x plus pi over 2x. What are we supposed to do here? We can collect the like terms. Of course, we've simplified that using the calculator, and this one will give you pi over 4x. It will give you pi over 4x. So simplifying this, Down here we can have P will be equals to 20,000 over X minus 25 over X pi, then plus 2x. Of course, if you look at these two already we've simplified these two, and this one gives you pi over 4x. So this is what we'll replace here. So this one will be plus pi over 4x. Now, what are we supposed to do here? If we consider the first two terms of the perimeter function, both of them are expressed to x as the denominator, and also the last two terms of the same, both of them contain x. So what we can do, first we can express the first two to a common denominator, then we factorize x in the second, so that we'll have p equals to 20,000 minus 25 pi, and since these two are expressed to the same denominator, we can divide this one by x. Then we add to here 2x and pi over 4x. We can factor out x, so this one will be plus 2 plus pi over 4, then into x. And remember, this is what the part B wanted us to show, so we can write here hence shown. So this marks the end of part B. Now we can consider part C. Going back to the question, we've done clean work. Going back to this, part C says use algebraic differentiation to find the value of x that gives the minimum value for p, giving the answer to 3 significant figures. So in other words, part C, we are required to, we can underline this, it gives the minimum value. We can highlight this. So use algebraic differentiation to find the minimum, to find the value of x that gives the minimum value for p. So in other words, we are required to minimize p and express the solution to 3 significant figures as given in the question. So this means that so first we are solving part C. So part C here will be minimizing p. So remember, already we are given p to be equals to 20,000 minus 25 pi x power -1 divided by x just the same as x power -1, then plus 2 plus pi over 4 x. Now what we can first get here, we know that at minimum point definitely the derivative is 0, so I will want us to get the derivative dp with respect to, so we'll have dp dx, dp dx should be it will be negative in bracket 20,000 minus 25 pi, then we reduce the power by 1, so this one will be x power negative 2. Then if we differentiate this, of course we'll have the constant 2 plus pi everything over 4. We can have this in brackets. So that is the derivative. Now, what are we supposed to do further? Definitely we can equate this one to 0. So this one should be equated to 0. So what are we supposed to do? We can take this one the other side of the equal sign, so that what we are going to have here is simply 20,000 minus 25 pi everything over x square should be equals to 2 plus pi over 4. Now, what are we supposed to do next? We can cross multiply. So that we will have 20,000 minus 25 pi. This one should be equals to 2 plus pi over 4 x squared. Now I want us to only remain with x squared, so it means we can divide through by 2 plus pi over 4. Then also this one divide through by 2 plus pi over 4. So these two will cancel, and what we are going to remain with, x will be equals to, of course, before we simplify this, I will want us to express the denominator here, 2 plus pi over 4, as a single fraction. So expressing this as a single fraction, let me just pull it here. So 2 plus pi over 4 as a single fraction. So we can have this over 1, and this one will be, of course, 4 times 2 gives you 8. 4 times 2 gives you, this one gives you 8. Then 1 times pi gives you pi plus pi everything over 4. Now, simplifying this, we know that what we will have is 20,000 minus 25 pi everything divided by 8 plus pi over 4. Now, if we simplify this, it can also be written as, we can write this as, so this one we can say that x still will be equals to 20,000 minus 25 pi. Then of course this one we can multiply by the reciprocal here, which is simply 4 over 8 plus pi. So what we'll have here, the resultant, I think we can take 4 times everything in the bracket, so that x will be equals to 4 times 20,000 is simply 80,000. Then 4 times negative 25 pi, this one gives you minus 100 pi, and everything divided by 8 plus pi. So of course this one I forgot, this one is x squared, this one is also x squared. Now what are we supposed to do next? We can get the value of x, and you see, for us to get the value of x, it means we get the square root. So we can get the square root of this and also the square root. And remember, we are dealing with the real items, and x is greater than 1, so it means we cannot pick the negative. We'll simply pick the positive as the value of x. So let's find the square root of this. The square root here, this one will be the square root of 80,000 minus 100 pi everything over just a minute. So this one will be minus 100 pi and it will be, everything should supposed to be over. Of course, we extend the root to 8 plus we extend the root to 8 plus pi we're supposed to extend the root to 8 plus pi. So the first thing we can do, maybe we can simplify first. So this one will be 80,000 minus 100 pi this one divide by, we divide by in bracket 8 plus pi, and this gives you, yes, so we are getting the value of x as, we can say x here equals to, or x is approximately, because we are just approximating, x is approximately 7,152.1, the same thing as what we got from the calculator, x squared. Then for us to get the value of x, what we can do, I will want us to get the square root of this answer. So square root is approximately 84, so we'll have 84.57, so x here is 84.57, but the question said to 3 significant figures, so it means x is approximately 84.6. So that marks the end of part C, because we've determined the value of x. Now proceeding to part D, we can also finalize with part D. Part D here, going back to the question, that is going back to the last part, part C says that part C, by considering d squared p over dx squared, justify that the value for x found in part C, so we are considering this. This is what we are considering. The value of x found in part C gives the minimum value of p. So we are using the concept of second derivative, and you see there's something, a concept that we need to know here, that if the second derivative is greater than 0, then definitely it is a minimum point. So that is what we are banking on, if the second derivative is greater than 0. So here we can say that if d squared p over dx squared is greater than 0, then it will be minimum. So what are we supposed to do? We are supposed just to differentiate. So we know that you are given dp over dx to be equals to negative 20,000 minus 25 pi x power negative 2, of course, plus 2 plus pi over 4. So getting the second derivative here, we'll have differentiating this again, we'll have 2 into 20,000 minus 25 pi. Of course, this one will be over x cubed, then the constant here tends to 0, but this itself should be greater than 0. So what do we need to do? Of course, here we know that the value of x is simply greater than 0, or what we can do, you can cross multiply here. So we'll have 2 into 20,000 minus 25 pi. This itself will be greater than 0. So simplifying this, here we can just key this in the calculator and find out what it gives us. Find out the value. So we'll have 2, open the bracket, 20,000 minus 25 pi, close the bracket. It gives you 39,842.9. So this one gives you, we'll have what we are going to have here is 842.9. Of course, this one is greater than 0 because it is a positive number. So we can say that we have d squared p over dx squared to be greater than 0, hence minimum.